Yo, what's up, everybody? Welcome back. Today we are working on our QR code scanner, kind of. We're actually working on visualizing clustering algorithms, but I promise it's related. Context. We're working on this QR code scanner, right? And we've kind of got it working in this like idealized case. Our QR code is perfectly axis aligned, and the whites are perfectly white and the blacks are perfectly black. And that's great. But some of the things we have to do on here require some form of processing on this image. We're making a bunch of assumptions right now that our data is perfect. So an example is, if you look at these red dots here, these are kind of representing where we think there could be potential finder patterns, these like corner codes. I mean, the idea is that we go like line by line by line, and we say, okay, do we see this pattern of like one chunk of black, one chunk of white, then like a 3 wide chunk of black, followed by a white and a black, right? And right now that only ever really triggers in both X and Y directions in the corners where we want them, and we can use that to find the QR code. Another example of something that we're doing is we're like looking at these timing codes. So these red blocks are representing what is supposed to be an alternating white and black section. And we use these to kind of say like, well, on a big QR code, we have like a guess at how big each block is supposed to be based off the finder size, but sometimes that doesn't work perfectly, and so we can kind of adjust that by walking this line and saying, okay, I counted like 15 flips, and they averaged this distance, right? And that lets us then pick the module size and then walk the whole thing. Now, where this starts to get interesting is we want to start working on real QR codes, right? So I Googled QR code bar menu and then kind of like hacked it up a little bit to kind of show the worst case that I'm thinking of here, right? So imagine you're at a bar, it's dark, your phone is shit. Maybe your phone's fine. My phone is shit. And its camera is really bad. And so its low light performance is going to be kind of grainy. There might be a shadow on the QR code. And so you go like, okay, how do we apply those same concepts to this QR code? And, the first thing that I want to point out is like this histogram on the top right. So this is showing, given a selection in GIMP, it shows you how many pixels are at a specific brightness. So here we're seeing like a peak at 0, which means that there's a lot of like fully black pixels. A kind of like spike in the middle here, which we can kind of assume is maybe light areas in the shadowed region, and then another spike on the very right-hand side that's kind of representing maybe light pixels in the brighter region. If we like take a selection of this, we can see that there's actually like quite a large spread of potential brightness values. So maybe we want to do something like we want to apply a blur, and then at the very least we get like maybe more of a like defined peak, because like then some of the noise goes away and you get kind of like a better average brightness overall. If you like select the whole thing, we start to see, oh, there are 3 peaks here. So what are these 3 peaks? It's probably that this middle one is the kind of light section under the shadow. This guy is the light section under non-shadow, and this is probably darks on both cases. They're probably the same. And so the question I'm asking myself is, how do we go from this data to yes and no in QR code? Or another situation, if we're looking for these finder codes, say that we accidentally trigger, we find like a couple samples. We have like lots of guesses that it's in the top left, lots of guesses that it's in the top right, and then like 1 or 2 guesses that it's somewhere that it's not supposed to be. How do we make sure that we're only looking at the samples that we care about and averaging the samples that we care about? How do we make sure that we're blocking off these 3 finder codes? Or if we're walking these timing patterns, how do we make sure that like if we made a mistake, how do we make sure that we're only taking like the average of good samples, not bad samples? And all of these questions kind of align with this concept of like clustering. So you have like, data. How do I right? You have like a bunch of points in some dimensional space. Those cases were mostly one-dimensional. I think the finder codes were 2-dimensional. But how do we like group them together, right? So we've looked at a couple algorithms. One of them is Diana. So she splits them up basically based off distance. So she says, okay, we start with one big cluster, and every time I take a step, I'm going to take the thing that's like farthest away from everything else and assign that to a new cluster, and then try to pick things that are close by here. So if we step a few times, we start to see, reasonable clusters form. Another one is agglomerative. So he's kind of like the opposite of Diana, where we start with one cluster per point, and every time we step, it will merge the closest 2 points to each other. So these algorithms are good for, we don't know how many clusters that we have, but we kind of know maybe a good stopping condition. Like maybe we stop when there's like a certain density in our clusters. Maybe we stop when a certain percentage of our items are in one cluster, that type of thing. Then there's k-means clustering, where you start by saying, hey, I think that there are 3 clusters in here. And just kind of like adjust yourself until you find the appropriate spot for those clusters based off of like distance to these points. So what happens is you kind of like initialize with some like random positions, and then kind of like shuffle yourselves a little bit. This is a bad example because they're so sparse. I think this guy seems to work better if we have like more sparse data. So let's look at like maybe doing something like this, and then you can kind of see the motion a little better, right? So he kind of like, you can see him kind of adjusting to try to pull his points into the right area. This guy we were having troubles with, where depending on where the points are initialized, that has like a large effect on the final position. So I'm not really sure. I think that there are cases where this might be a useful tool. It seems like when you look up how do I cluster points, this is like the first one everyone talks about, but so far it feels like the worst one to me. Okay, so that's all of the context you need, I think. Today, I want to work on, hopefully this is the last day, because I think that we've kind of like covered concepts enough that I feel like pretty comfortable with the different strategies now. But there's a couple more. DBSCAN, so this guy's like a density-based one. So we were looking at proximity-based ones for the divisive and agglomerative clusters, and then the k-means is kind of like a, I don't know what they call it, like a one where you set the initial groupings. DBSCAN is like, I want you to only look at clumps that have a certain amount of points in a certain radius. And then AP clustering is some sort of like statistical approach that I don't really understand yet. So I'm hoping we can just kind of like jump into those and see what happens. Okay. DBSCAN. So if I understand this guy correctly, they have this, the whole thing is built off of this range query function. So they use it here and here. And this range query function just basically says for every point in our, for all points, I think in database DB, I think they're talking about every point in the whole set. Run our distance function. And if our distance function returns that the point, this point and the points around it, sorry, how do I say this? Go translate the pseudocode and don't ask questions is my go-to approach for statistics stuff. I feel like if the goal were to implement these algorithms, I would agree. There's a lot of times where you look at the code on Wikipedia and you're just like, I don't know, but it works. But what I'm trying to gain here is I'm trying to gain an understanding of the strategies, because I suspect that I'm not actually going to use any of these guys. I just kind of want to get like, what are they working with? And like so far, the ones we've looked at, actually none of them are doing anything complicated, right? Like Diana's just saying like, take part far away, split to new part. Like, and agglomerative is just like, take part close together, stick together. And then the k-means is like, try, look close by, match up, please, right? So that's why I'm going through a little bit more in detail, because I'm kind of hoping that we gain strategies for dealing with signal processing in general. Okay, so this guy's saying, go over every point, and he's then saying, I'm going to add a point to this set if the point is close by, essentially. So he's basically saying, I want close points. Give me all of the points that are close to this one. Cool. So he starts by iterating over every point, and he says, which ones are close to me? And he says, if they are close by, if there's like a lot of close by points, then we'll do something with it. But if there are like only a few points that are close by below some thresholds, then we'll just say, we don't give a fuck about this one, right? So you can imagine that like you have like, 15 points over here and 1 point over here. And if your distance is like, threshold is like, something like this, you look at this guy and you go, this guy sucks. Like nobody cares about him. He has no friends. Nobody loves him. So we won't love him either. We'll just delete him. We don't give a fuck. That's what this is doing. Then here they're saying C is C++. So I guess this is cluster counter. Right. So just making a new cluster and they're assigning the point to that cluster. Right. Okay. So here they're saying, okay, we found 1 point who has lots of friends, a popular guy. And we like popular guys. Everybody likes them. And so here we will say this is their new cluster. Mr. Popular is the new cluster. Then this is saying, look at all of my points that are close by, but ignore Mr. Popular, I guess is what this is. So S is just so if this was the region, say we picked, we'll draw them in red. Say we picked a guy like right here. I guess we would draw our little circle around this guy. Maybe dashed lines look a lot like points themselves because I drew them so shittily, so I'll draw this in blue or something. So he's kind of saying, S is this whole cluster minus the red point, which is me. I want to be Mr. Popular now, so I'm going to call him me. He's going to say, look at these guys, and if we previously labeled them as noise, so we can imagine that, like, this guy, maybe he was, like, friend adjacent, right? Maybe he was over here, and he's, like, in this cluster. It's hard to, I can't, like, really draw it out with this example very easily, I don't think. Well, yeah, sure, maybe I can. So say this guy's over here. He's right here on the edge. And so if I draw his circle, he's friends with these guys, including Mr. Popular, but he's not friends with any of Mr. Popular's friends up here. And so previously we would have said, okay, he doesn't have enough friends for us to consider him a cluster, so we'll call him noise. This guy's saying, like, okay, so if we previously called this guy a noise, he's like a friend of Mr. Popular. We're chilling. Like, he's one of us now. Otherwise, if we previously considered him part of a cluster, then we ignore him. We say, well, every group can only have one popular guy, I guess. Maybe not? No. This is saying, this is something else. This is like, if you have, I'm not 100% on this. I think I have like a bit of a gut feel that it's something like this guy also has a lot of friends over here. And maybe like this point is better friends with this group than that group. It's something like that. Otherwise, we consider all of Mr. Popular's friends part of his friend group. And we look for the neighbors of this guy. Oh, okay. So we find his neighbors. And if he... so we like extend the friend group for each point. Sure. Okay, that kind of makes sense. That doesn't seem too crazy. Nothing about that seems like crazy hard, I don't think. We'll find out once we start implementing it, but it feels okay. Why can't I foreground? Why does it think that this is being edited? Oh, I hate that shit. Okay, so background on application structure. We're writing in Zig. We are running a web server in Zig because I didn't feel like figuring out any GUI frameworks, and I kind of feel like a web server is one of those things where any language where you have a TCP server, you can bang out the world's shittiest HTTP server. And we're kind of lucky that browsers have to support every shitty web server that's ever existed, so you can write like the n+1th shitty web server, and the browser probably will accept whatever you do as long as you do it like within reason. So the idea, like my thought is, if I improve this skill of working with shitty web visualizations, it'll extend to anywhere, and I should be able to bang out anything pretty quick. That's kind of like the goal there. So we have like this server, and he wraps our like application. So our application is where all of the actual like thoughts happen. So our app is this like, he owns a little bit of like a clusterer interface as well as points and clusters. The server like requests from the application, hey, could you tell me your clusters and your points and maybe some like extra debug data that goes with your clusterer? And then he sends those off to the web client. The client renders them in the little HTML canvas. So what we're going to do here is we're going to say we have a new clusterer and his name is DBSCAN. And we need to make rules for what to do if somebody asks for a DBSCAN. So we'll make like a new implementation of our clustering interface for DBSCAN, and then we will be able to construct that somewhere. I'm just looking for something that I can copy paste without having to think too hard. Do you know Raylib? I've heard of it. I worry about tying myself to immediate mode GUIs that have no forward path for accessibility. Because in my mind, it's like, what's the fucking point? Right? Because like any time that I'm gonna like actually make a real application, I'm going to use something where like if I'm releasing something, like I need like I think there are like maybe, well, first of all, there's like empathy, right? I would hope that if a blind person wanted to use my program, they could. But there's also like legal requirements that you can run into, so it would kind of suck if you like built something around an immediate mode GUI where that's like actually just not possible, and then like get hit with this like legal requirement later. So like I probably would never tie myself to a GUI framework that doesn't at least have like a path forward for that type of thing. And so while something like Raylib could be pretty nice, it's like, do I really want to invest my time in learning that type of tool when I could just get better at HTML and that'll work everywhere? You know what I mean? Or if I'm going to do something like local, like wouldn't like maybe it's better for me to get familiarity with Qt or something instead. Anyways, that's my thought on it. I'm not sure if that's like reasonable, but it is how I feel. And my feelings are valid. You can't stop it. But I will say that it does look nice. I have been Googling a little bit like C GUI libraries, and it does look like the most like sane one. Shockingly, it just seems like there isn't a good C one. There's like a bunch of there's C++ ones. But if I'm just like trying to work in raw C, I guess if I were to write a desktop application in Zig, I guess the approach that I would have to take is write some Qt in C++ and then add some C glue that I can hook into Zig, which I've done that approach before. It's not too bad, but it's like it would be nice if there was just like a C library that did what I wanted. Okay, this guy is going to create a DBSCAN. I guess we'll call it DBSCAN clusterer to match the API. Desktop GUI is a big mess anyways. Yeah, I believe that. I forgot things about Nuclear. Yeah, I think Nuclear probably falls into the same category as Raylib though, where you just have like you're gonna get hit with the same problems. Where I think there's no accessibility path forward. I think I could be wrong. I could be wrong about both of them, for the record. It could be that like those immediate mode GUIs, they do something like they push a bunch of widgets into some buffer sometimes, like with a bunch of like draw calls, and it's possible that you could maybe snoop that in some way. Okay, so our reset function right now, we're gonna say he does nothing. We don't really know what he's gonna do yet. His next function, we also don't know what he's gonna do yet. But we do know he's gonna be a DBSCAN cluster. I think the rest of this is all fine and dandy. Okay, so is there what is like our initialization here? And is there steps to this like there are in other algorithms? In other algorithms, there's like some initial state, and as you step, something kind of happens, right? How do I, this is servers down. But in DBSCAN, it kind of looks like you just do the whole thing in one shot, right? You iterate every point one time, and you just fucking call it a day. So I guess our next function in this scenario, it's almost like we don't even want a clusterer. Like the cluster interface is kind of built around the idea of stepping through some algorithm and retrieving intermediate state. It does kind of feel like this guy's just, boom, you're done. I guess we could consider our loops per point. Yeah, let's do that. We'll say each iteration of our loop is 1 point that we're investigating. So it looks like they kind of just go point by point in any order. Yeah, that seems fine. If you're on a hardware accelerated surface, I guess most people use IMGUI, but there's a C version called CIMGUI. But if you want proper accessibility stuff for route rendering, so you should probably use something like Qt or WX widgets. Yeah, I think that kind of sums up my feelings on it. Yeah. I think most people use IMGUI in C++ land, right? Like in C, do people use the C bindings? I guess like I've been hesitant to pull in a project like that, but not like IMGUI, like the C bindings, because I don't really know like who's maintaining them and stuff. But yeah, IMGUI is pretty cool. I've used it a little bit. It's pretty sick. Pretty sick. Okay. I'm gonna make some progress. So let's just make our little function range query. And he's gonna take in the points. And he takes in our distance function. We'll just hard code it. We'll take in the point ID that we're looking at. Point ID, which is going to be index into the point database, and then our epsilon. We can hard code that for now, or maybe we'll store it here. We'll give it as like a parameter. Eps is going to be a float. So maybe here we pass in epsilon as a float, and then we say clusterer if eps is equal to eps. There we go. And so then we can take an epsilon here, and he's going to return what? This is saying I return a set of neighbors. Okay, so this is going to be like a bunch of points IDs that has to be freed. Okay, so I guess we start by implementing this loop. For each point in the database, call distance func less than epsilon. Okay, so for points, I guess we have to do for 0 to points len, we have some index. And if I is equal to point ID, we skip. We don't range query ourselves. Otherwise, we look at points I. We look at the distance. I think it's distance to, yeah, points, point ID. And I think that this distance to function wants const pointers, so I probably have to put an ampersand here. And we say if this is less than epsilon squared. And the reason we're using squared is because you're like Pythagoras is a squared plus b squared equals c squared, but then like you don't want a square root because square rooting is like a little expensive, so you can just work in square space and then it's fine. So we'll say const eps2 is equal to eps times eps, and then we'll say if this is less than eps2, we add it to some set that we're returning. So let's make an array list. And we have to initialize them with some allocator. And I'm kind of hoping that there's some way to go from array list back to just like raw slice that we can free ourselves. I'm kind of assuming that's true. I don't know how true it is though, but we'll see. So we'll say var neighbors, let's do this. And here we just say neighbors dot append with this I. And then, oh, 2 on slice, perfect. So I should just be able to say return errors 2 on slice like this. Which I assume is going to like shrink the thing to match the current size. Yes, they resize aligned alloc, clear and free. Yeah, okay. Oh, this says... So this makes a new thing, copies the internal buffer into the new buffer, then frees our memory. So here I just want to error defer neighbors dinit, I guess. And hopefully, does this handle like double dinit? Yeah, it does. Sick. Cool. So now we have our thing. We're saying we're going to represent each step in this guy as 1 point. So we'll say const point or point ID is a usize. This is going to be initialized to 0. We will say when we're done this guy, we'll increase our point ID by 1. And probably we have to say if self point ID is greater than or equal to points len, we just return, nothing to do. Cool. So here we say const neighbors is equal to range query with our allocator, with our point ID, with our points, and with some epsilon. Okay. And if this succeeds, we have to free this guy after this iteration's done. We have to label the point. So maybe what we'll do is we don't really have this like concept of noise, but maybe what we'll do is we'll just make like a noise cluster. Yeah, because like the way our visualizer works right now is he only ever renders points that are clustered. But maybe we don't have to do it that way. Sure, we just won't put them in the cluster. I think that's fine. We'll deal with that on the visualization side later. So I guess that just means all points are noise by default. So we'll just say if neighbors len is less than min self min points, continue or return. Return, nothing to do. Which kind of means here we probably want to for min points is going to be a usize. Min points is a usize here. And we have to propagate that thing over like this. Okay. Okay. Now we create a new cluster. So we say cluster ID is our clusters, add cluster. Boom, new cluster activated. And we assign the cluster, the point to that cluster. So we'll say clusters add to cluster, cluster ID and self point ID. Okay, simple so far. Now we iterate over all of our neighbors. And we do the same range query. And extend the neighbors set with those points. Is that what this is saying? This, okay, change noise to border point. Okay. Otherwise, so if it's previously noise, we add it. If it's assigned to a different cluster, we do not add it. Which kind of indicates that we have to check every cluster, which is maybe a little expensive. Because right now our clusters are just like arrays of points. But for now, we'll just kind of call that fine, and we'll deal with it later. So we'll say function point already clustered, and he will take in a point ID, and he will also take in the clusters. And I guess he will just say var cluster it is equal to clusters cluster iterator. While there is another cluster to look at, we look at the cluster, and we look at every point in there. I guess we can just say a std mem index of scalar, and we can say, hey, is there a thing in this cluster? So I think it's index of scalar takes in the slice first, then the value. So we look for the value of point ID in the cluster. And we say, if this is something, we return true. Otherwise, we get through all of them and return false. Okay. Which means here, we can go through each of our neighbors. Neighbor ID. And we can say, if point already clustered, neighbor ID and clusters. Continue. Otherwise, we assign it to us. So, clusters add to cluster, given the cluster ID and the point ID. Boom. Then we say const neighbors is equal to try range query self alloc self point ID points self eps. Boom. And if neighbors is greater than or equal to self min PTS, okay, what's happening here? So for each point, neighbors n is equal to this, then we add this to the cluster. Okay. Now we have a problem here where our cluster doesn't handle duplicates right now. So I don't think we can just blindly add to cluster here. Or here, really. Well, here we know it's a new cluster. We don't. Because he might have been hit by a previous neighbor. So for both of these guys, we're going to have to do like a little like add. I guess maybe this has to handle that. Do we want to say that our add to cluster function has to handle this? That doesn't seem crazy. So we can say, hey, let's look for this point. And if it exists, nothing to do. Otherwise, we append it. Okay. Now we don't have to worry about it. We can just say for if this is greater than this, then we say for neighbors. Add the neighbor to the cluster. Okay. Oops, this should be neighbor ID here. And this should be defer neighbors.d no. Self alloc free neighbors. Which kind of means that we should have done this up here as well. Not dinit. And maybe we're chilling. And then we increment I. I guess on reset, we clear the clusters. I don't know if that's handled externally or not. They're initialized freshly on init. We do reset them, but it's fine. It's technically not wrong. Okay. I think that's fine. Nothing to do here. Bloop, 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 bloop. Okay. So now on our server, if somebody asks for the DBSCAN cluster, we have to construct him somewhere. So let's look for wherever we construct Diana. Here we go. DBSCAN. And DBSCAN has some parameters. He's got epsilon and min PTS. So what we're going to do is we're going to have to figure out what those params are. So I guess we will set some defaults, walk our query params, and if they are there, then we will set them. So we have eps is a float 32, and we'll set him to some default value. It doesn't really matter. And then we have neighbors as well, or num points, was it called? Min points. This is a usize, and we'll set this to like 3 by default. I don't fucking know. Doesn't fucking matter. And so then we will look for eps, and we will also look for min PTS. Simple. So here, min PTS is equal to a usize parse, and then epsilon was actually a parse float. And I don't know, I think there's no base 10 in parse float. And then here we can call with eps and min PTS, if that's the right order. Eps and min PTS, chillin'. Chillin'. Might work. Who knows? Who knows? Let's get a second environment so that we can run the server and still edit code. Just give him a sec, he's got to think. Come on, buddy. You can do it. I believe in you. There we go. Zig, build, run. Of course. If it compiled, I would have lost my goddamn mind, to be honest. It never compiles. So he doesn't like that. Oh, right. We forgot to store the interface. That's the most important part. So with these, I call it C-style inheritance. We're kind of like working with this mechanism where the concrete implementation, he has like a pointer, or he has like a member of the interface. So his parent is a parent here, parent, and then he hands out pointers to the parent, and based off of this parent pointer, the parent will have like a v table inside of him where he'll have like function pointers to our implementations, like we're assigning here. And he does this thing where he goes well, I, the parent, am at address 1234, and I know that I'm the first element of child, so child must also be at address 1234. Or if there's other data in here, he'll be like, ooh, that's 4 bytes. I know that I'm the parent and I'm 4 bytes away from my child. So it's important that he stores the cluster interface here. Okay, error is ignored. So that's here. More. Points already clustered. So this is also probably a try. Does this ever return an error? No. So I'm just I think by habit, I just put the exclamation point there, and it would be nice. I would like Zig to warn me if that's an unnecessary error. Because it just noises everything up. Makes it harder to compile. Okay. Neighbors, I forgot to type length there. So this is neighbors len. And error is ignored again. And I think we're compiling. Okay. So now we should be able to go to DBSCAN. And right now, we need to fix our visualizer so that any points that weren't in a cluster get rendered as black dots or something. And I think probably what we can do is we might be able to get away with just rendering all of the points outside of a cluster and then rendering them again inside a cluster, because I think that the way the canvas works is it will draw the second thing on top, and so we'll just we'll just draw on top of the black dots, and that's fine. So we can say, we'll make a function that's render point, and we'll take in the canvas context, as well as the point to render, as well as its color, I guess. Then all of this stuff can just be copy-pasted here. with some magic numbers in here. Shut the fuck up, it's fine, we'll live. And so here we'll just say for point in this cluster, we get the point and we render the point with the context and the point and the color. And then we will just, before we do any of this, we will just say for point of data points, and we will render it with black. Boom. These guys need to be passed in canvas, scale, canvas, offset. Canvas, offset, boom, like this. Okay. So now we get a bunch of black points. Nice, and we step. Nothing fucking happened. I also don't know if he's just like railing CPU. No, it's just nothing happened. Could be that our clusters are not... Okay, let's start with like a cluster radius of 3. And we'll make one cluster, maybe 2 clusters with like 50 points each or something. Okay. So that's doing something, for sure. That's a lot of clusters. So maybe we need to adjust our... Let's add the parameters here. So right now what I'm doing is I'm just giving all parameters for all types of clusterers all the time. Because I don't want to think about it, and I'll just know which one is which. So we'll have epsilon and num means. Or not num means, sorry. Min points. Yep. And then when we ask to set the clusterer, we'll just shove those as query parameters. Fuck it. So we have eps is equal to eps, and min pts is equal to min pts. And so we have eps and min pts. Eps min pts. Okay. Maybe? We can always dream. Okay. So let's look at what we send. So we set with DBSCAN, we set clusterer, eps 3, min pts 3, and if we look at what we expect to see on the server side, we can look for, we are looking for eps and min pts. I think we're chilling. Might work. Okay. So let's say that we want our epsilon to be bigger. We want our clusters to be allowed to be 6 large. Okay. So what's happening here is it looks like we're kind of like looking at the same cluster over and over again. And because like the epsilon is like, I think it's like just a little too small for that cluster. It's not like propagating correctly, I feel like. Like there's way too many clusters here. There's something not working correctly, for sure. For sure. So let's go back. We'll go back and we'll look at... Okay, so we have some cluster ID. We're always making a new cluster. Which seems like we shouldn't be. There's like an exit condition we've missed here, right? It's this one here. If it's already in a cluster, we have to exit. So that's just here. If point already clustered, self point ID, we return. Nothing to do. And we rebuild and rerun. Let's try that again. Okay, DBSCAN. So step, 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 step. And actually let's do this whole thing in a loop. So that I can continue here, and so that every time we type step, we at least get we get a new cluster. Every step should give us an extra cluster. That's ideal. Okay, DBSCAN. Okay, so step, step. Well, I didn't see a second cluster come up there. What happened? Okay, step. Whoa, 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 whoa. Oh, fuck. I fucked up. I fucked up. I fucked up. I fucked up. We need to break at the bottom of here every time, unconditionally. Yeah. And then here, this should also be a continue. Yeah. Yeah, something like that. Fuck it. Refresh, refresh. DBSCAN. Step, step. Whoa, 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 whoa. Okay, so that... I think that we saw some flickering here, but I think that that's related to points that are on the border could be in either cluster. And so I think they're kind of saying like, hey man, it's okay. Maybe. Like the flickering might be by design. No, because if it's already in a cluster, we're supposed to ignore it. So there shouldn't be any flickering. Let's make maybe 3. Let's reduce the number of points so that we can see them a little bit more clearly. And let's make our clusters a little bigger so that they're spread out a little more. There we go. And our epsilon... So maybe we'll say epsilon will make this bigger, like maybe 8. Okay, so did anything weird happen there? Step 1, we have these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We are missing some points if I count them out. So that could also be related, where it's possible that like some points are just covering each other. So can we like maybe cluster radius like 7, make them even more spread out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, I guess it's because it's like a Gaussian distribution, so they're just likely to stay towards the center. So maybe... I guess we'll just look at the data and check. So here, we saw our first cluster has 1, 2, 3, 4, 5, 6, 7 items. Next, our cluster has 1, 2, 3, 4, 5, 6, 7. Okay, fine. So here, this was a border point, and the border point changed. Right here. Right, we went from... Oh, maybe not. So... Oh yeah, 15 is in 2 clusters. It's a fucking bug. That shouldn't happen. 14 and 15 are both. Okay, what the fuck is going on there? Because we were supposed to be saying if the cluster is already... If point already clustered continue. If point already clustered continue. So it's possible that point already clustered is not doing what it's supposed to do. Oh, we're supposed to maybe do it... Oh, they're not doing it down here. So probably we'll stop seeing that like flickering if we come down here and do this. I think. We need to recompile for that to apply. Because this is a compiled language, believe it or not. Oh, I guess it doesn't help that the cluster color is also changing. But yeah, we are not seeing that happen anymore. We did crash, which is a little concerning. Point ID is out of bounds at 577. So what the fuck is going on here? So this is coming from here. Self point ID. Oh, oops, we have to do this check up here. We are missing a check. This one. This guy has to be in the loop. There we go. Oopies. Okay, so I do feel like I stopped seeing the flickering. Like, the colors are flipping back and forth, but like which elements are in which cluster are not flickering anymore. Where if I take this check away, like it had in the original, we're basically allowing clusters to end up in, or points to add up in multiple clusters because they're considered border points, I think. Right, like here we saw this point here move from the blue cluster to the green cluster. And that'll be indicated in here where we're going to have duplicates. So 20, 22, 31, 37, 39. 39 is in both. Which I don't like. I don't like. 4 point in the database, if it's less than epsilon. Okay. Yeah, so I don't really see anything indicating that that shouldn't happen. I guess like we have there, they did mention the term border point here. So if there are core points and border points, and that's allowing border points to flicker, maybe that's okay. If this was previously processed, we continue. Okay. Oh, hold on. We're missing this. We're not doing this. We're saying if the point is noise, then continue, but there's something about like, if we've looked at this point at all. Right. Okay, so we have to track ourselves which points we think are noise. I think. I'm pretty sure, and then we can say if it's in the cluster or we've considered this point noise before. I think. Maybe. Noise points is an array list of usize. When we reset, well, I guess here we have to initialize this thing. So var noise points is equal to try brain fart. Holy crap. Array list of usizes. We have to initialize this with our allocator. Error defer noise points dinit, just in case. And then here we say clusterer noise points is equal to noise points. Boom. Okay. On reset, we clear the noise points, which means that we need ourselves. We say clear and free. Boom. Okay. So we need to check a little again here. So if the point is undefined, is not equal to undefined, then continue. So we're not going to call this point already clustered. We're going to call this point already seen. And here we'll look at the clusters and we'll do the same thing. But we will also look at the noise points. Yeah, I think that's reasonable. So we'll call this const usize here. And we'll say if stood mem index of scalar for usize of noise points looking for point ID. If this gives us back a number, we return true. Okay. Which means that every time we look at these guys, we have to adjust this as well. Points already seen. And did I get that in the right order? I think I did. Yeah. So this is My brain, man. Self noise points items here. Okay. Now, here we need to check the noise. So if it's noise, maybe here we'll return where it is. Point status. Yeah. Yeah. And he's going to either be a noise point or clustered. And here we're going to return or unseen. Yeah. I like that. Point status. Here we return that. And if we see it as clustered, we return clustered. Here we return noise point. Here we return unseen. And then we can get a little bit crazy here. Point already seen. If this is not equal to unseen, we continue, like it says in the algorithm. Then on these guys, we can check if it's noise. So we'll say const neighbor status is equal to this. And if neighbor status is equal to noise point, and then here we have else if neighbor status is equal to clustered. If it's already a cluster, we continue, but if it's a noise point, we assign it. Yeah. So here we say, this is also going to end with a continue, I think, based off what I'm reading here, right? Here he assigns it, then he checks it immediately. So this is also going to skip it. And if it's a noise point, then we remove it from the noise points list. Which kind of indicates it would be nice to know, we already should know the index of the point. So we can actually make this like a union enum who has a noise point, which is going to contain a usize, but everyone else is going to be void. And then here we can switch on the neighbor status. If we have noise point, we have some index, and we can swap remove that IDX. And then add this to this cluster. And then we're chilling. If it's a clustered point, we just continue. And the other thing, unseen, we just do nothing. That feels right to me. Yeah. Okay, let's try that. Let's see if that looks a little more sane. He doesn't like something here. 48. This is no try. That's why. This is, the initializer always succeeds, just allocating sometimes fails. But there's no allocating when you first initialize an array. Okay, go away. I don't give a shit. Noise point. Return noise point here. I have to say, hey, I'm going to return a union element whose noise point value is equal to this index. Yeah. I think that works. Yeah, that works. Okay, so now we run and refresh, and let's try looking at this again. So you can go DBSCAN, step, step. So I still don't like what I'm seeing there. We are definitely seeing duplicates still. It's like fucking annoying. Fucking annoying. So where are these duplicates coming from? Like it has to be that. I'm almost positive it's this. Am I missing some obvious reason that that's not supposed to happen? It's this. If the label for this point already exists, then we like fuck off. Oh, so I'm supposed to do this here as well. In fact, I'm only supposed to do that here. No. For point in Q. So this is, or for Q in S. So this is all of my neighbors of my core point. I do this check. But then for his neighbors, I don't do that check. But like, am I high? I feel like clearly I should do that check. Like this seems like this is important as well. Unless he's okay with relabeling. Find points in the neighborhood. Find the connected components. Assign each non-core point to a nearby cluster. Otherwise, a knife destroys neighborhoods in step 1. I'm missing... Like, maybe it's okay? Okay, so... Core points should all end up in the same cluster and not move. Border points should not. Like, maybe border points are allowed to move between them if they are attached to the neighbor of a core point. And maybe that's okay. I guess what we'll just do is if the algorithm's kind of saying that the border points are arbitrarily assigned, we can just choose the other way. Right, we can just do this check here. Yeah. Is not equal to clustered. Yeah. I'm okay with that. Neighbor status here. Neighbor status here. Okay. Because, yeah, I just don't want, like, the instability. I don't want things to be in multiple sets. So I think that's reasonable. So let's try this again. Step, step, step. Yeah, now I definitely don't see anything moving between clusters. Now, I don't really like the fact that like epsilon here is too small. So I think probably what we want to do is in our index.js, make sure that when we change the epsilon value, that it reinitializes the clusterer with the new values. So where do I do that? I do it somewhere. Set clusterer. Ah, here, yeah. So here we'll just add one of these to epsilon and one of these to min PTS. Boom. And now I should be able to go back to DBSCAN, step a few times, be like, I don't like that. Let's increase our epsilon. All right, maybe a little bigger. Okay, that's not too bad. This epsilon value is like a little sensitive. But overall, not the end of the world. Let's try maybe making more clusters with a bigger radius with more points as well. Let's get like 100 points in here. Okay, let's kind of see how this looks. So interestingly, oh, with my min points of 0, that fucked up. I guess that makes sense. So is there anything here that, so here, yeah, we did actually manage to get into a scenario where there aren't enough neighbors for this guy, which is kind of interesting. Let's like reduce the epsilon a little bit. Okay, so that's kind of cool. I do like that this is the only algorithm so far that has the ability to create, how do I say this? Like, ignore points. I don't like this. That looks fucked up. This also looks fucked up. So there's something wrong here where we're getting clusters with 1 point. which I feel like shouldn't happen. I feel like that shouldn't happen. So what could cause that? I guess we're checking that like we have a certain amount of neighbors, but then here we're like not assigning those neighbors to that cluster. So maybe this is actually good. Maybe we do want this, like, we do want this. So maybe what we should do, maybe what we'll do is we'll also return the cluster ID that it was clustered in. So here we'll return clustered with the cluster item cluster ID. And then what we can do is if we see that a point is clustered here, we'll just remove it from the old cluster. Let's try that and see what that looks like. So we can say a switch neighbor, or can you do like if neighbor status dot clustered? Is this allowed or is this going to crash? I don't know. We'll see. Old cluster ID. And so if this is the case, we will remove it from that cluster. So we'll say try clusters, remove from cluster, old cluster ID, and the neighbor. Yeah, that's fine. You can compare union enum like you just like enums. No, I'm more worried about like if it's the wrong enum variant, if this is going to be considered like an invalid access. But I think this will work. If it compiles, it'll work. Expected optional type found use size. Oh yeah, so this isn't valid. I have to do a switch here. Right, and then just do clustered old cluster ID like this. And then else do nothing. It would have been nice if I could do like the if syntax there, but I was, syntactic sugar, not the end of the world. 564. Expected error union type. Oh, this guy can't error out because we assume that if you're calling it, you fucking know that the point's in there. And if you're wrong, then fuck you. And by fuck you, I mean fuck me. Okay. That's not good. Oh, interesting. So I guess we're maybe removing points from the cluster because they're... Oh, we're also just not adding them back. Add to cluster. I accidentally deleted the most important line. All right, let's try that. Let's try that. So go back to DBSCAN. Hello? Oh, fuck me. I ran the server twice again. God, I do that so often. DBSCAN. Okay. Let's get this little step. Okay, yeah, so now we are seeing, like, this guy is, like, fighting over these border points. But that's okay. What I don't like is, like, why the fuck did this orange guy end up in a cluster? Like, I do feel like there should never be a cluster that has one element in it. Oh, I guess we're just having the same problem now, where it's, like, removing the border point from a cluster that we already checked. So, I guess... maybe, like, by definition of the problem, like, I guess we can make this decision however we want in, like, whatever circumstance we're using this in. But maybe you should consider border points in two clusters. Maybe that's the only way this makes sense. Right? Like, if we're saying that we have, cluster... say we have this setup, right? And we're saying, like, hey, we want... clusters of 4 elements. Never give me a cluster that has less than 4 elements. Like, in this scenario, like, this is a valid cluster, and this is a valid cluster. And so these points kind of need to be in both. And maybe that's okay. Interesting, interesting, interesting. Okay. I guess that's not like the end of the world. Or what we could do, the other option is we could purge a point here, right? We could purge this point from this cluster. Like after we've done our reclustering for each point, we could maybe like go at the very end, just go and remove any clusters that have less than min points and delete them. That's not crazy either. And both approaches seem fine and reasonable, right? Like I think that would be, like we can try that right now. So what do? We say after we do this, we walk all of our clusters for var cluster it is equal to clusters cluster it. And then we say for cluster it cluster item if cluster item len is less than self min PTS. My maze crashed. Why? That's okay. Well, you know what? We don't need it every day. You guys will live one day without it. I don't want to deal with it right now. Okay, so if I'm less than min, is it less than or equal to? What are we doing up here? It's less than. If it's less than min points, we have to clear the cluster. So usually what I do here is iterating while modifying is sketchy, but we're not actually going to delete the cluster. We're just going to set the cluster to empty. So no, we will do it that way. So we'll say std var to remove is std array list of usize initialized with our allocator. Here we defer to remove dinit. We say try to remove append with the cluster item cluster ID. And then down here we say for to remove items. And then usually you would actually do these backwards, but I think it's fine. Clusters clear. No, there's a function on here to remove from clusters. Well, we can only remove a single point from a cluster. We can't clear the cluster. You can remove in a loop if you use loop plus swap remove and don't increment while you swap remove. Yeah. That's true. We'll just say pub function clear cluster with a cluster ID. And we'll just say self clusters items at cluster ID. Clear and free. Boom. And then I guess we also are going to add all of these points as noise points. So we're gonna go for cluster item cluster, something like that. Cluster point. We're gonna do something like self noise points dot append cluster point, and then clear cluster with the ID. Okay. And this is while cluster IT next, actually. Okay, I think that works. I'm not sure. No field len in cluster item len. Why not? Oh, this is a cluster dot len here. Yeah, something like that. Something like that. Clear and free. So this probably needs self-allocator. No. What is going on here? So this is a... Oh. Oh, yeah, no. So clusters has array list unmanaged. Oh, yes, yeah, so it's self-arena allocator. The allocator needs to be passed in because there's some, like, things moving around on stack shit going on. Okay. So let's zoom out a little bit. It didn't work. It didn't work. We still have a green element. So what's going on here? Why isn't that fucking... What the fuck? What the fuck? What the fuck? So we have, if the cluster line is less than self min points is 3, we remove. And then we try to remove. And clear cluster clears and freeze. Hello, clearing cluster. Clearing cluster. Let's just see if that fucking gets hit. Like, am I high? DBSCAN, step. So here, like, what the? It's just not getting hit. So we're never to remove append cluster ID. If cluster item cluster len is less than self min points. Okay, so if that's not getting hit, like, I mean, he clearly should be getting hit. We have one with one fucking point in it. Can we just say, like, hello? Maybe I should put some \n's on here. Just to see. Hey, how did you do that website? Just a little bit of hand-rolled, simple HTML, right? Like, everything's going on in this canvas, and then a little bit of JavaScript. So in the JavaScript, we just kind of like render to the canvas based off of the data coming out of our web UI, and we're just serving it directly out of our application. Yeah. Okay, so here, theoretically, you should be saying hello. If you want to see code, it's on GitHub. Same, it's the GitHub link in the Twitch description, and then it's under clustering viz is the name of the project. Okay, so here he is saying hello here, so he's getting to this point, and then he just must never be hitting this condition. Why the fuck not? Why the fuck not? GDB zig out pin clustering viz, and then we'll break on this. We'll hit run. We'll go here and we'll go DBSCAN, refresh DBSCAN, and we'll hit step. And we hit this. Okay, so self min PTS, self, or we have cluster item cluster len 19. Continue. Step again. Whoa. So here, we added this point, and we must have exited early and not hit this point part. Oh, fuck. God damn it. God fucking damn it. I was in one indent level in from where I wanted to be. God fucking... I hate writing bugs. If only there was some way to avoid this type of problem by, like, splitting out your big function into smaller functions that have names and are very clear and can fit on one screen. If only I could have done something like that. But it's impossible. So we're just gonna keep going. But if that were possible, that would be the way to fix that. Okay, does purple still only have 2 in there? I only see 2 in purple, but it does have 3, so it's probably just that there's one that's like underneath something else. But I do kind of like the way that this look feels a lot better. I kind of like the way that ended up. So let's try this again. So let's try to set like min points to like 5 maybe, and maybe we'll kind of increase the cluster radius here a little bit. Reset. Maybe a little less. Okay. Yeah, I kind of like that. So here I can say I really want like really dense sections that are small. That's not bad. That's pretty fucking sick. Yeah, I like that. This is super useful. Super useful. Why am I not hitting anything? Oh, because I accidentally changed the step size. Yeah, that's super sick. Super sick. So here I can say, well, I'm okay with like less points now, and these guys like expand a little bit. Oh, that's so cool. That's so fucking cool. Versus like fucking k-means. I mean, I get that they're just doing different things. I get it, but this feels a lot like what I want for my specific problem, right? Which is that like we have samples, we want to discard outliers, and we want areas that are like pretty dense. This feels like a really good fit for that. So pretty cool, pretty cool. Okay, an hour 20. The question is do I think I can do AP clustering in 40 minutes? Because unfortunately I am a little bit scoped on time today. Well, okay, let's see. Say it takes an hour, it'll be like a little bit close to 4:30. I have to leave. Yeah, no, that's fine. Okay, we'll do it. Okay. DBSCAN done. And we will move on to AP clustering. Very exciting. Okay, so AP clustering, I have like a lot less of like a... So far, all of the algorithms we've looked at, I feel like I've been able to say like at a high level, like put things close together, big into one cluster, put things far apart, split new cluster, like move average, find things close by to point, right? Or like find areas of density. All of those kind of like make sense to me. This one does not make sense to me yet. But what they do is they have a function S that quantifies the similarity between 2 points, such that S, okay, so that like comparing I and J and I and K will be greater if if J is a better match, right? So bigger number, more likely to be the same cluster. For example, negative squared distance of the 2 points. Sure. Diagonal is particularly important as it represents the instance preference. So this I don't really understand. How likely a particular instance is to become an exemplar. I don't know what an exemplar is yet. When it's set the same value for all inputs, it controls how many classes the algorithm produces. A value close to the minimum possible similarity produces fewer classes, while a value closer or larger than the maximum possible similarity produces many classes. It is typically initialized to the median similarity of all pairs of inputs. Okay, so they're kind of saying you have this function, but the function has to return like a special thing on the diagonal, and we'll figure that thing out later. The algorithm proceeds by alternating between 2 message passing steps. Calling something message passing here is confusing to me, but that's okay. With 2 unique matrices, which update two matrices. The responsibility has values R, I, K that quantify how well suited XK is to serve as an exemplar for XI. The fuck is an exemplar? Availability contains values that represent how appropriate it would be for X to pick K as its exemplar. Okay. So the A matrix is like, let's see if we can draw it out. If I understand what we're saying correctly, we might have like points like this, and maybe I'll draw it a little bit different. No, I will draw it. Let's draw it like this. Here we go. Okay. So here, if we call this A, oh my god, A, and we call this B, call this C and D. I think what it's kind of saying is like one of these matrices, responsibility matrix says, quantify how well suited XK is to serve as the exemplar for XI. relative to the other candidate examples for xi. Okay, so maybe like C and D for A are going to have like an equal R square, right? Because both of these guys are like equal distance, if that makes sense. They're both like pretty good fucking candidates for A. And D is equally good for A and B as well. But the availability matrix is saying this is how appropriate it would be for A or B to pick this value as its exemplar. So I think one of these guys, I'm not like 100% on this, but it feels like they're kind of saying one of the matrices is accounting for the fact that A should pick C here and B should pick D here, right? Even though these distances are equivalent, A has like a second OK option and B doesn't. I think that it's something along those lines, but I don't really know yet. But that's like kind of like my gut feel based off what they're saying here. Like one of them saying from the perspective of the object, and one is from the perspective of the candidate, and one is from the perspective of like the clusterer or whatever the fuck you want to call it. Both matrices are initialized to all zeros and can be viewed as log probability tables. The algorithm then performs the following updates iteratively. First, responsibilities updates are set, and the responsibilities are set by the distance function minus availability plus distance. Okay. Then availability is updated by taking the minimum of 0 and... Oh, Jesus Christ. Okay, what the fuck is this? RKK. What the fuck is RKK? That... Oh, RKK is the responsibility matrix value, and the responsibility matrix value gets set by looking at the SIK minus the maximum of all other points, something like that. Maximum of K not equal K. We'll get there. We'll get there. Okay. So he gets updated according to this. So he's saying, take the sum of all of the maximum responsibility values. Sum of the maximum of all responsibility values. But isn't this responsibility value negative? No, because he subtracted another negative value here. So he's saying I'm summing all of the responsibility values of all of my neighbors or something. And here we're updating the availability matrix by saying take the maximum of all of my responsibility. Dude. Okay, so kind of the extent of how I understand this is two matrices updated by some formula, don't fucking get it. Whatever. And then assigned based off of this. So debugging this is going to be fucking hard. Probably what we should do is maybe it'll make sense to visualize these matrices. Looking at this, I'm not even like sure that I understand what the dimensions of these matrices are. I guess it's just like number of points by number of points. Probably. I guess maybe it makes sense to we'll just fucking try it. And probably what'll end up happening is it will make sense to visualize the matrices themselves. Oh, and that's going to end up taking a lot of time. Fuck. If this was start of stream, this would be perfect. Starting this now feels sketchy. And I would be willing to do it if I wasn't tight on time today. Oh, and I don't want to do another day of this fucking density streaming stuff, but it's okay. Fuck, man. Okay, I think that this is probably going to be interesting enough to spend tomorrow on. And I apologize for pulling a little switcheroo on you guys and like baiting you into thinking that we're going to do it today. I think, yeah, it just looks complex enough that if the extra visualization is probably going to make it take a little bit more time. And then probably I assume that we're going to have to spend some time looking at that visualizer and intuiting. So what we'll do is we'll come back to this tomorrow. And if we get through it quick, then we can just jump on to like actually doing some QR code parsing. And if we don't get through it quick, then it'll means it's interesting enough to keep going. So I think that's fine. So thanks for watching, guys. Apologies for the bait and switch. But if you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Today was a 1.5 hour stream because just the timing didn't work out right. So if you're on between 2 and 4 Pacific time, which is right now it's 3:30 for a gauge there. You could swing by and see what happens if you see what's up. If you want to say hello, if you're new here, there's a YouTube link and a GitHub link in the Twitch description where we have playlists of our previous projects as well as source code that go with them. Trend in there is just like whatever the fuck I feel like, but whatever the fuck I feel like trends towards low level stuff. So you might see some like Rust operating system, you might see like Python neural network, you might see virtual file system, you might see a diff tool that we wrote ourselves, that type of shit. There's more in there. We wrote like a game engine, like the shittiest version, that type of shit. If you're watching on YouTube, there should be a Twitch link in the YouTube description. And if you're online and you want to say hi, feel free. Otherwise, I think we'll call it there. Yeah, thanks for watching, guys, and I'll catch you on the next one. Bye!